In the previous module, we discussed and demonstrated the ease with which an attacker can decompile an Android application. Understand that this attack is also possible for the other platforms. However, it's more difficult and it doesn't reveal the source code in as readable a form. Nonetheless, you should be asking yourself, what can I do? You should feel exposed. So we're going to look at a technique called obfuscation. Obfuscation is a fancy word that means making something more difficult to read or understand. We'll show you obfuscated JavaScript code, some simple examples and a more complex example, and make a blunt recommendation. Also, we'll explain the limitations of obfuscation. So, is decompilation an issue? Clearly it is. We've showed you how easy it is that an attacker can, in seconds, decompile your Android application to reveal the client-side source code, to be able to see the API that client code uses to talk to the back-end database. They can apply the same static analysis techniques that we as developers would use to find vulnerabilities to the source code, and they have a running copy of your example code to be able to reverse engineer the back end. So this is really a big issue. What can we do about it? We can obfuscate that code and make it more difficult to read. Now, this creates a situation where the attacker has to spend more time to try and decompile and understand your code. And what we hope by doing this is to create a situation where your code is harder to read than some other victims, so the attacker will devote his effort to the other victim. So using an example, this is standard JavaScript, and we use JavaScript simply because it is simple. The techniques apply as well here as to any other language. And you'll see that in these two blocks of code, we're assigning a variable called error level, and we're setting it to the value of 4. We terminate that statement with a semicolon, then provide an inline comment to say that the error level shows alerts. The next line, we define a function called log error. It takes 2 arguments, where string and message, and then the log error function calls another function, log common, provides 3 arguments to that function. 3, error plus the where string and message, and you see another inline comment. And at the bottom of the page, we define the log common function. Pretty simple code to understand. Now consider this code and compare it to the previous code block. They don't look like they're doing the same thing. But if you compare closely and carefully, you'll see they are functionally identical. We declare a variable, we assign it a variable name, in this case Q, and the value 4, and we terminate that with a semicolon. Then we define a function name Y, and we give it 2 arguments, A and B. It calls another function, X, and passes 3 arguments, 3, error plus A, and B. Then we define the function X, just as in the previous slide. What have we done? We removed the comments, we removed the white space, we removed the carriage returns, the tabs and indents, simply to make it a denser, harder to read block, and we changed the variable names to single letters. Now, we do this commonly with JavaScript to reduce the size of the script. JavaScript, remember, is transmitted from the server to the client and executed typically in the browser on the client. So by applying minification, this specific technique, I reduce the amount of data that must be transmitted and that must be parsed before it's executed on the browser. It's a speed technique. It also makes the code difficult to read. But that's not all we can do. We can apply other obfuscation techniques in addition to minification. I can do a moderately difficult thing called injecting dead code. This would be the insertion of additional variables, additional functions, which are never referenced or used by the application. And I can use more complex encoding of the strings and variables within the program to make them more difficult for a human to to read. So let's look at our example again. Here's our starting block, same as before. Now consider this block of code. Limiting ourselves to that first variable definition, you can see I declare a variable name starting with a Z. I use the equals operator to assign it, and then parentheses indicates do some math. I add 0 by 550 in hexadecimal encoding to 1066 in decimal encoding, and then I subtract 0 by 976 again in hexadecimal, and I close my parentheses. If you do the math in a programmer's calculator, you will see that those three numbers sum up to 4. And I terminate that with a semicolon just as before. If you follow the rest of this function or the rest of this block of code through, you will see, once you undo the encoding and the math, that it equates logically to the exact same as the previous block of code. It's just more difficult to read. Automated tools are available to help you obfuscate your code. There are commercial and free versions available. Google can help you find these tools, and we recommend you search for Code Obfuscation. If you bring your code, your application, into the Center of Digital Innovation, the CODI, at the TRA here in the United Arab Emirates, one of the many things they test your application for is to see if you have obfuscated your source code. We and they strongly recommend that you do obfuscate your source code. Thank you.